Hello my friends, and welcome again to my video channel. Today in part 2 with the MFJ998 I will tell you the status regarding soft, or better said firmware, of this PIC inside. This week I tried to read out the data from the PIC. I failed. A friend of mine who has experience told me very simple that there are protection bits. They are obviously set, so it is not possible to read out the data. Makes sense. The manufacturer doesn't want this. There are two other options I have. First, I contacted here a big dealer in Germany. They promised me to do their best to look for a replacement. MFJ is out of business. That's a problem. But obviously they have contacts into the US, so maybe there will be a solution to acquire a new PIC, original PIC, from any stocks. I don't know where these stocks are, but when they are okay, then it's also okay for me. A third option would be to try to analyze the programming program from MFJ. I've got running successfully on my laptop, you have seen, via the RS-232 interface. There's a program called didn, I think it's didn spelled. This is an analyzing program. It looks like it is a very powerful program. The program is much more powerful than I am. That's a problem. Maybe I manage it with some help of skilled guys here to analyze the PIC programmer and to see which data are transferred from the laptop into the tuner, to the PIC in the tuner. So it will take some time, especially the response from the dealer. So we can focus now on another topic, which is also very bad in this tuner. By the way, the PIC is in again, the original PIC, and it is working, still working, but without frequency indication. There is another problem which has to be solved. The problem of this board is bad solder connections. The SMDs are not the problem. The problem are these toroids. Here we have a pad which is not soldered on the top. You can see it. It is not soldered on the top, only on the bottom. It cannot be soldered on the top because the copper wire is enameled, and the enamel wasn't removed before it was fed in. This enamel is, as I assume, solderable. This means with heat it can be dissolved and disappears, and then the copper can be soldered, but the temperature wasn't high enough. And this is the problem of all these big toroids here. All these toroids have the problem. This problem also appears on ground connections. I have here a ground connection, an example. You see here, it is not soldered on the top, it's only soldered on the bottom. So all these connections have to be resoldered. For this purpose, the toroids have to be taken out. The copper has been cleaned, and then it has to be resoldered again. As I see here, someone tried. Where is it? Someone tried to do this work, but the quality of the work is extremely bad. Well, how to take it out? It can be flipped out when we remove the shield. By the way, a second problem here is the screw, which is broken inside. We have to take out the shield, and then we can loosen the screws on the bottom side to make this rear panel movable, and then the whole unit can be flipped out. That's what I will do now. The bottom cover can be flipped out. A lot of screws, and the coils, ferrite cores, are out. And now we have them on the bench, and we can remove the enamel, the paint, some millimeters more, so that we have also the option to solder the wire not only on the bottom side, also on the top side. Similar with this coils here, I did it already. We soldered it. This will be also done with these cores and fixed with cable ties. And then the problem should be avoided, that the connections here could burn by overload. You may ask why there could be an overload. Well, the unit is specified for 1500 watts. When we calculate 1500 watts into 50 ohms, the current is 1500 by 50 and root. It is root of 30. That is 5 to 6 amps, which is the current in the case of a 50 ohm system. When we have, for example, a 20 ohm load, a low impedance antenna, and we have 1500 watts in it, then we have 1500 divided by 20 is 70. Root 70 is something between 8 and 9 amps. And this is a high frequency current, considering skin effect. So it is a good idea to have contact on both sides of this trace. We have here double traces on top and bottom side. For example here. And same we have here. And this is valid for all others. So there are two traces on top and bottom, and we should also have a contact. Of course, yes, it's a via, it's a conductive via, so it should be theoretically sufficient to have soldering on the bottom side only, but I don't think it's a good idea. And also this wire here for the capacitors should be resoldered on top and bottom side. Well, next step is to remove the enamel and replace these ferrite cores. The enamel is solderable, so it can be removed with a hot iron, a big iron. And then you see the enamel is burned away. And then we have a bigger area, and then we can solder it also from the top side. Ah, it's hot. It's really hot. And then we can use a knife or something like this to remove the burnt enamel. There's always something left which shouldn't be there when soldering. And then we can insert it into the board again. We start with the cores which are inside. It's easier to access it. Later it's difficult when these cores are installed to solder here. Now we can solder on the top side, here and here, and also on the bottom side, of course. It is done step by step. Okay, not necessary to show you everything in detail, how to solder. I think you know how to solder. All ferrite cores are in. They are now also soldered here on the top side. An example is here. Don't know whether you can see it, but it's obvious that they are also soldered now on the top side, as it should be. They are secured with cable ties, as we can see here, soldered also on the bottom side. So this topic is solved now. The cores are soldered better. I've seen that the relays are soldered very well. I don't do anything else. There are always two contacts, as we see, in parallel for switching over. I will bring in the board and then we can focus on the next topic, and this is a broken front panel. The board is reinstalled, all screws are in, and all soldering blobs and soldering beads which could be found here are removed. The board is cleaned with a soft brush or similar. Especially the SMD part here does not like to be infiltrated by traveling beads or so. It has to be cleaned carefully, very carefully. Now I found by a visual inspection that this capacitor is missing. It is C192, and in the schematic it is this capacitor. C192 forward power, which is fed into the PIC. It's a filter cap, and it is connected directly here to this pin of the pot, wiper of the pot, and this is the forward power from the bridge. I don't know why someone has removed this capacitor, no reason, and it's a little bit difficult because the PIC will get different time constants here in the input. I don't know whether it is relevant for the automatic tuning, but I can imagine that it is not the best solution. When one capacitor is missing, the other one is present, so we have different time constants. And the PIC compares, of course, forward and reflected power. And when there is a different time constant, I don't know what happens. Anyhow, I will reinstall it. It's 1 nanofarad. And I think I have an SMD 1 nanofarad in one of my boxes. And now a safety hint. It cannot be repeated too often. Ground yourself with a ground strap. Ground the chassis to the same ground point and ground the soldering station. Here we have the wire, and all the other soldering stations here also grounded. They are all on the same potential of the ESD mat here, so there will be no problem. I have a theory what happened, but I will discuss this theory when we have this unit running again. And then we can place and locate and solder this little capacitor in place with a small tip. That's one of the smallest tips I have, and I will do this. The last problem is a mechanical problem. Here we have a tape to fix the front panel, the keyboard, but this is not good. Obviously the screw is broken, so we have to remove the tape, flip out this board here. There are 2 screws, so you can see it. There are 2 screws holding this board. On this side, it's a crazy construction. Where is no mechanical stress, there are 2 screws, metal screws, into obviously metal bolts with metal screws fixed. That's okay. And here, where we have the high pressure of the key, we have only 1 screw, which is obviously drilled into a plastic bolt, as I see. Okay, let's open it. And no, it's not a plastic bolt, it's also a metal bolt, but there's a screw missing. Simply a screw is missing. But the problem is, the screw is behind this flat cable. I shouldn't have installed the main board. Oh no, oh no, oh no. But everything is okay, mechanically. Only the screw is missing. Why is it missing? I don't know. I don't know. Okay, I removed the board, the main board again. Took also away the keyboard, the board with the keys. I found that there's another problem, that these holes here, the square holes, are a little bit too small or not cleaned thoroughly. There is a ridge inside, so when we activate the key, press it in, it does not come out easily. Sometimes it is stuck in the on position. So I will use a file and clean all these holes a little bit, a fraction of a millimeter on all sides, just to have the hole a little bit bigger. But of course I have to be careful not to damage anything. I will cover it with some paper. Just to indicate you what I'm doing, I'm using such a small file, and then clean it on all sides a little bit. This has to be done 8 times. The additional screw is in. The other 2 screws are okay. And now we can activate all knobs without problems. And then we can reassemble the whole unit again. Hehe. Double work. Should have first thought about it. This screw is installed. Now the keyboard is in the place as it should be. The holes are big enough. Shield is installed. Main board is installed. Now we can switch it on and off. Very easy. The knobs are operating. You will see the picofarad changing. Antenna 1 and 2. Okay. But obviously it reacts. Well, now the last and the biggest topic is the pick problem. I am waiting for the solution. I'm sure you are also waiting for the solution. So let's see what the solution is. I got a new pick, programmed pick, MFJ998 RT pick, 1 unit. The dealer supported me, very quick and reliable. The pick is in, but we have the same problem. 0 megahertz. I connected 7 megahertz, 7.2 megahertz to the input. I measured the signal at pin 6 of the pick. Another single shot we see here. It's not a perfect square wave, but that's not relevant because, sorry, we show it a little bit better, because we have a Schmidt trigger input. That is the signal, and the Schmidt trigger input accepts such a signal. We have 5 volt, 0 volt, it's really 0, 2 volt per division, so we have 5 volt peak. This is good enough for a Schmidt trigger input, but still 0 megahertz. I tried it with several frequencies, several inputs. So the peak is obviously not the problem. What is going on there? There's only one part left. I thought it isn't a problem because we have a display, but I looked into the data sheet of the display. The display also has a controller in it. It saves, stores and saves data. So maybe we have a problem inside this display. The display is available on the market. It only costs roughly about, I would say, 10 euros, dollars or so. It's not so expensive. I will buy one unit. I don't have this in my boxes here, so I have to buy a new one. I also will check all wirings on the on this board. There's a board behind. This will be the next step. But this will be part of the next video, of video number 3. We are at the end of part 2 of the videos about this tuner. You see, the repair is a little bit more complicated than I thought in the beginning. First I thought it's only the amplifier, the input from the transmitter connection. It wasn't, so I thought, okay, it's a PIC input. It wasn't. Now we are on the display. This will be part of part 3. I will order meanwhile a new display. Check also all wirings, traces, vias, all connections on this board. There's a small board inside from here to here. Maybe there's a problem with some of the wirings. Could be, yes, of course. So stay healthy, stay tuned. See you on this channel. And I hope with a little bit more success.